So this is section 8.2, and it is using the definite integral to find the area between curves. All right. So let's think about what we are doing here. I'm going to pause. All right. So what we have here is the red graph is y equals x squared, and the blue graph is y equals negative x squared. Come on, Michael. Okay. Now you can see my red and blue a little better. All right. And we want to find the area between the two curves. So when we are finding area between curves, we need to remember that we want that to come out to be a positive value. So we do not want to consider negative integrals giving us a negative portion of our answer. We are finding a sum of the total area, so it should be a positive value. Okay? So let's think about this. If I call this graph f of x, and this one g of x, let's consider the area under the curve of f of x from 0 to 2. Will that be a positive value or a negative value? Positive, and the area we're talking about is there, correct? Because when we find area under a curve, we're finding the area between the curve and the x-axis. Okay, so that one's going to come out to be positive. All right, well now let's consider g of x. So the integral from 0 to 2 of g of x dx will come out to be what? Positive or negative? That will come out to be negative. And the area we're talking about there is shaded here in green. All right? And I want the sum total of the areas, ignoring the signed part of it. So I would take, to get that sum total, I could take the integral from 0 to 2 of f of x dx, and then do what with the integral of g of x? Subtract it. Minus the integral from 0 to 2 of g of x dx. And simplified, we get this little area. The other class dubbed it ABC, area between curves, to be the integral from a to b of f of x minus g of x dx. Okay? So the one I've shown you here has our second function causing a negative signed area. And that's the trickier one to understand why it would be f of x minus g of x, so that's what I wanted to show you first. When we do our first example, it's easier to see, again, why did we do f of x minus g of x. So let's take a look at our next example. Actually, prior to that, let me show you how I want you to think about these and set these up as we do them. So, in calculus, we always think about a sample one, a very tiny sample, and then we sum up all those samples over some interval, right? 3-month sums, the problem we just did with population density. We do it all the time. So what I want you to think about is a rectangle, a representative rectangle in the region that we are interested in, like this red one. And if I find the area of that rectangle, and then I sum all of these similar rectangles from 0 to 2, then I would have my area between the curves, yes? Okay, fair enough. All right, so when we use these vertical rectangles, I want you to think about, when you're setting up your integral, as the integral from a to b of the top function minus the bottom function times the thickness of this one rectangle. So what is that thickness going to be called? dx, good. So to find the area of this one rectangle, I would take the top function minus the bottom to get the height of that rectangle, times its width, which is dx. Okay? And then we sum up all of those similar rectangles. I do want to see the sample rectangle because it will save you from making errors on the harder problems. Okay, so I want you to draw in that representative rectangle. All right, so that's what we'll be doing. So everyone is clear that when we look at this rectangle, our top is up here, and our bottom is down here. And to find that distance, you do top minus bottom. Yes? Okay. All right, so now let's look at that first example. So in this one, and I'll try to make it a little bigger for those of you in the back, we have, this is an exact AP question. It's a portion of a free response question on the calculator active part of the exam. And most times when we see these types of problems, which is quite often, they like to put on area and volume problems in free response. I can't guarantee it'll be there, but it often is. It's generally on the calculator active. And quite often they say set up the integral but don't integrate it. Or if it's on calculator active, they may ask you to integrate it and you'll do it with your calculator to be as quick as possible. This would be one part of usually 3 or 4 parts of a free response. And all of the free response questions are 9 points each. Generally, I would say this one little part would be 2 points. We need to remember that if you get about half of all the points on the AP test, you're going to get a 4. Okay, so if you can get an easy 2 points out of 9, you should be very, very happy before you read on to the other parts of the problem. Okay, so I want you to always be very careful to get these correct. All right, so let's look. We have region R is the shaded region bounded by the graphs y equals the square root of x, and y equals e to the negative 3x, and the vertical line x equals 1, as shown in the figure above. Find the area R. So the first thing I want you to do is draw in your representative rectangle. I'm trying to color it in without making it a mess. So there's our rectangle. And I'm going to call this point right here A. So now tell me how to set up my integral in terms of A. Integral from A to 1. I'm going to stop you there. So when we have these vertical rectangles, as they stack, as we sum all of them, they're going to be stacking this way, correct? So that's why we're going from an x value A to x value 1, because our stacking is happening from left to right. That changes when we deal with horizontal rectangles. So we need to make sure we understand that. So we're going to go from A to 1. The top function, which is square root of x, minus the bottom function, e to the negative 3x, and then we have dx. So I am telling you, this was on a calculator active portion. The integral is done. What's the only thing you need to find before we can continue? We need to find A. You have a calculator. Solve this problem. Find your A, set up your integral, and solve. And I'm going to remind you, because it wasn't this time, I'm going to remind you how I do my integrals on my calculator. I do not do it on the graph screen. I do it on the home screen. So you can just do Math 9, which is FN int. You know that you will never write this phrase FN int on any test ever, because that is not math, that is calculator. But I'm showing you how to use the calculator, so I'm writing it. Okay, I generally put my two functions in y1 and y2. So I'm going to make this one y1 and this one y2. And I am going to write y1 minus y2, comma, you tell us what variable we are integrating with respect to, and that is x. And then from what value to what value. So from A, which you'll figure out, to 1. That's how you enter it on the home screen. Okay, question? Yeah.
Something like that.
Then you're going to, is it the actual integral?
Yeah.
So, you're going to put in your A value here, your 1 here, in this box.
You just put an alpha A.
Yeah. Oh, no, you find out what A is. I'm just showing you how to set it up. You need to calculate that intersection. So we'll have the y1 minus y2, and then I think it has a d something, dx here. Is there anything else we need to plug in on the 84? Okay, I think that's it. Okay, all right, to find the intersection, we need to remember second calc intersect. First curve, second curve, so you move your cursor to be right on top of the intersection, hit enter, and get your answer. Now this gets a little trickier when we have more than two functions that we're dealing with, and I'll talk about that on our next problem. All right, so what is A? What is it? About 0.239. All right, remember to leave that as long as it goes, 0.238. 8, 7, is there more? 1, something, I don't know.
3, 4.
Thank you, 3, 4, whatever. Leave that as long as you can in your calculations and do your rounding at the end. Your rounding or truncating, okay? All right, and do we have an answer? It's 0.443. That's where the rounding or the truncating can happen. Our solution is 0.443. All right, I see people looking. Are we okay? Do we have it? Tyler, is it all right? You coming up with something funny? Let me look. Let's just correct this now. Yeah, you have to zoom in. Really go back to the all right. Everybody else? You got it? You guys got it? Ladies and gentlemen over here?
What do you, I'm just wondering what you do into the calculator after you get that, if you get that 443.
So then we put in that FN int. So after you get your A, you're going to let your calculator do your integral for you. This is math9. And put your square root of x in y1 and your e to the negative 3x in your y2. And then we can just do bars, y bars function to get our y1 minus y2, comma, x, comma, whatever value you got, 0.23874, comma 1. Okay? Everybody else okay? Yeah? Okay. All right, yes?
Why is the integral 1 to A?
If we went 1 to A, then you think about our direction being negative, right? Right to left is a negative direction, and it would cause a negative value to come out. So we always work from left to right when we're summing up our rectangles vertically. And when we're summing them, when they're horizontal, you work from bottom to top. Okay? If you like to do it from 1 to A, you could stick a negative in the front, and then it would be all right. Okay? All right. Let's try another one. Okay. I'll make this larger. Stop. Ooh, not that far. Yeah, it's separate. I added that one later. Okay. This is also an AP problem. They both were. So, let's take a look at this one. So here's why plugging into y1 and y2 is really a helpful thing. Take a look at the function we're dealing with this time. X cubed over 4 minus x squared over 3 minus x over 2 plus 3 cosine x. We would not want to type that in multiple times. Okay? And there's lots of places to make mistakes when you're typing it in, so be careful about that. All right, so that is our function f of x. Let R be the shaded region in the second quadrant bounded by the graph of x, and let S be the shaded region bounded by the graph of x and the line L, which is the line tangent to the graph of s at x equals 0. We're not going to do part C right now. That'll be a challenge later. We're going to do part A. Find the area of R. So, when we think about this one, can you tell me what the top and bottom functions are? All right, so we're going to integrate. I'm going to draw my little rectangle. Kind of. There it is. So, top function is what? Well, they told us it's this. It's the function, right? Yeah. So the top function is f of x. What's the bottom function? Y equals 0 is the bottom function. So when we set up our integral, we're going to have the integral from somewhere to somewhere of f of x minus 0 dx. Now, do you have to write minus 0 for me every time? No. But I need you to understand that we're still doing top minus bottom. Just the bottom in this case is y equals 0. Okay? All right. And now I want you to do this at your desk. You need to find your lower and upper limits and solve the integral. I'll roam around. Ask me questions as you're working on it, please. I really want to make sure we're clearing up all of our questions about using that calculator to find our integral. Like this guy. Stop me if you need me. Okay, how are you? Yeah? Did you get your function in? Yeah. No, I thought I was. Pretty good? You know what you're doing? Connor, can you even see back here? It is hard. Do we have the light on? So, I think these are, you can't just assume there's one. Actually, so your calculator can find zeros for you. So this time you've got to find the intersection function. You know how to find zero? Yeah. Maybe? Yeah? Are we doing all right? You know how to do them on here? Ladies? How are we? Oh, zoom in. We're way close in on, make your window just -2 to the 2. I mean, x is -3 to the 2. Where's the other guy? Oh, that's all one function.
But I thought we were supposed to do it like that and do the separate.
Only if there's a top. See, this is the top function, that's the bottom. On ours, the top function is the sum of all those values. That's the top function. Minus the bottom function is 0.
Okay.
So the top function, f of x, is that whole thing.
So it's keep the bottom function being negative. I know, but I'm just.
Oh, I'm sorry. This one, yes. Yep, the bottom one was either x, the top one was where is that?
Okay, so.
Top is
integral is off because they're.
Look at your, yeah, so look at your rectangle. Where's the top of your rectangle? Right here.
It's this whole thing. That's all one function. And then here's the bottom of your rectangle. What's your bottom function? Do that top thing minus that. Right?
Question? Yeah.
Oh, I haven't seen that. The integral is just, so what I would rather do is not bother you. Ours is, yeah, okay. Nothing to work, that's what you're doing.
So that's your top.
Oh, it doesn't. I have to use my calculator when I did it, and it was one. Yeah, so it's my wife's school, that's what 1 0. And then I thought,
You can do that, Sarah. I find it takes a little longer when we're at the phone screen.
That's okay.
oh, wait, oh, yeah.
So far, well, I'm gonna look there, right?
Can they, oh,
On the bottom, grab that partner.
I wanted more correctly. But I might even.
All right. So, the part we needed to realize on this problem was, okay, so, we needed to find, listen up, eyes up here, we need to find this point first, so we know our lower limit, and what is that x value? Negative 1.37312. 1, 2. All right. So that's the one that goes down here, and what's the one on the right? It's just going to 0. So our integral is going to go from negative 1.37312 to 0, and our functions y1 and y2, well, our y1 is this whole thing, x cubed over 4 minus x squared over 3 minus x over 2 plus 3 cosine x. That's our f of x. And what's my bottom function? What's my bottom function? Y equals 0, so minus 0. So that's what we're doing, dx. Now, as I said, put this whole function, put this whole thing, y1, so you don't have to retype it time and time again. Okay? And what do we get for our answer? Give me more 3 decimal places. 2.903. 2.903 sounds familiar to me. Okay? Questions on that one? We're getting a little more clear on what we're doing? Okay. All right. Now it gets fun. Here we go. Am I okay to leave this screen? Okay, I'm going. All right. Because this is fun. All right. So the region that I want you to find the area of is this. Okay, we should know. We should know which is which, because one's a line, one's a sine, and one's a...
Yep, I got it.
Okay, good. All right. But I would, right off the bat, listen up.
Yeah.
Listen up. I'm going to call this one y1, this one y2, and this one y3, and I'm going to put them in my calculator in that order. Okay? Now, I'll let you do that in just a minute. I want everyone looking up at the screen first. So, what is different about this example? Andrew? We are going to use all 3, and how are we going to use them? Tyler, what do you think? No? You sure? All right. So, how are we going to, what's the problem? What's the issue that's going to happen? Yeah.
Some of it is negative on different parts and positive.
And our regular f of x minus g of x should take care of that. You are correct. Sometimes it's above the x-axis, sometimes below. But something else is going on here. Maddie?
Well, I think on the two and probably intersection.
Okay, so here's, how many intersections do we need to find? One here, number 2 is here, and number 3 is here. But I haven't heard yet what we have to do differently now. We have to have 2 integrals, indeed. Because if I draw my rectangle over here, oh boy, big fat rectangle, right there. If I draw that rectangle, what's the top function? Y, Y1. And what's the bottom function? Y2. But if I draw it over here, gets a little crazy. What's the top function? Y3. And the bottom function? Y2. So I need 2 separate integrals because there is a change in our interval as to what the top function is. So let's write out our integrals in terms of a, b, c's, and y's, and then you can go ahead and solve. So I will have the integral from where to where? A to b. Of what minus what?
Y1 minus Y2.
Y1 minus Y2 dx. Plus the integral from B to C.
Y3 minus Y2.
Yep. Y3 minus Y2 dx. Can everybody see why we have to do that?
Why is it Y3 minus Y2 instead of the other way around?
How do you find the distance,
Oh, right.
right, between this? I know, but everyone has trouble with it. They always say, why am I doing that? How do I find the distance between this point and this point? I do the top minus the bottom. Okay? All right. So, now define this, please. At your desk, find this solution. You need to find your intersections first. Now, here's where I will warn you. When you do second calc intersect, and we have multiple functions, you need to make sure you're picking the right one for your second curve by pressing the up arrow until you get the right function up in the upper left corner. If you have trouble with that or haven't done that before, call me over, please. Okay, so what is our A value, please? 4.071. 5, 6, that's good enough. And B? 6.37879. I heard that. And C? 8.01. 25. 448. Good enough. So once you have those, you should have x minus 5 to the third in y1, sine x in y2, and x plus 9 in y3. And then with your fn inch, you can set up this integral, this set of integrals, and sum them. Okay? Our answer should be 4.106. Remember, we, in this class, round to 3 or truncate at the third decimal. All right? Questions on that one? Okay. Let's see what else we can do. All right. So now, this next example we're going to do in 2 different ways. The first way is what we have been doing with vertical rectangles. It says, find the area of the region R in the first quadrant that is bounded by the square root of x. That looks like that. And the line y equals x minus 2. So that's going to look something, like that. Okay? All right. It says in the first quadrant, so the region that we are interested in is here, and not below the x-axis. So before we begin, we need to find these important points. So what's this one?
2.
It is 2. It is the x-intercept of the line y equals x minus 2. All right, how are we going to find this one? Set the functions equal to each other. We're going to go through and do it this time. Square root of x equals x minus 2. Sometimes we have to do these things by hand, so we need to practice. What do I do next?
Squares.
Square both sides. And what do I have on the right? Expanded.
Square minus 4x.
Minus 4x plus 4. What do I do now? Remove the x. So we have 0 equals x squared minus 5x plus 4. That's nice. Now what? X minus 4, x minus 1. 4. And I get x equals 4 and x equals 1. Are they both valid solutions? 4 is good. This is the point 4, 2. Why am I getting this other one? Because we ignore the fact that we're only dealing with the positive root here when we do our solution, so we end up getting an extraneous root. Okay? All right, so we have our solutions, our intersections, I should say. How many integrals will I need? 2. I will need 2 because of what happens right here. Right? Okay, so let's go ahead and write out our integrals. And I'll draw my rectangles so we can see what's going on. There's that one, and here is this one. To help us find our top and our bottom functions. Okay, so we have the integrals from where to where? 0 to 2 of square root of x minus 0 dx. There's that one, plus integral from 2 to 4 of square root of x minus the quantity. Very common error. People forget that parenthesis. The quantity x minus 2 dx. Go on your calculator. Get me an answer, please. While you're working on that, I'm just going to get my sketch ready for the next one. Oh, that's not right. 2, 0. All right, anybody have a solution yet? And it is?
3.333.
From my glasses. That is correct. 3.333 or 10/3.
3 1/3.
Or 3 1/3. All of those are correct. Okay. So, now we're going to do the same problem, but we are going to integrate with respect to y. So what this means is that we are now dealing with horizontal rectangles, which I cannot draw in this room, instead of vertical rectangles. All right, so a few things we need to think about. If I'm going to use horizontal rectangles, then I am no longer going to be doing top minus bottom to get the length. What will I do? Thank you, right minus left. So our integral would be right minus left, right function minus left function. And my differential will no longer be dx, it will be dy. Which means that all of my variables need to be in y. And it also means that my upper and lower limits on my integral would need to go from a y value to another y value. Whereas when we did it with vertical rectangles, we went from an x value to another x value. So our stacking now is going to be happening this way, one on top of another up like this. So instead of going from 0 to 4 for our integral, we will go from where to where? 0 to 2. Okay? So let's set up our integral. We are going to have the integral from 0 to 2. Now, can anyone tell me why this way might be better than the way we did first, Maddie? One integral. So this is why you want to look at the problem and say, should I do it with vertical rectangles or horizontal? Which one makes it easier and pure integral? Solve it. All right, so to continue, we need to change our equations to be in terms of y. So we have y equals the square root of x. And now we will have x equals what? Y squared. And I'm going to put a cloud around that because here is the most common error when we integrate in terms of y. Students set it up and they forget to change to be in terms of y. And they have x's and y's mixed together, and we cannot integrate with x's and y's mixed together yet. Eventually, but not in here. Okay? All right. So, and the other equation was y equals x minus 2, and that becomes x equals y plus 2. All right, now we have everything we need. So take a look at my little representative rectangle. Here is the right function, and here is the left. So help me write my integral. From 0 to 2, y plus 2 minus y squared dy. Find that now. So, even though it's written in y, when we use our calculator to figure it out, you just put them in indexes. But now you're just doing an integral. You don't go looking for y. Okay? It could be p's. It could be w's. It doesn't matter now. It's just the integral that we're figuring out. So what do we get? Excellent. We should get exactly the same thing no matter which way we do it. Check. Question? No? Okay. Why does it say that? Very strange little approximating of doing. 10/3 would be the correct answer, ignoring the decimal. All right, so now what I would like you to do is, I have some good. Now, I'm running low on my lollipop. So we have lollipops, and I will be breaking the Nestle Crunch into shared pieces because this is not going to be a race. Anyone who gets it right may have some goodies. Okay, so it's not a race. I just want you to work on getting the problem correct. When you get it correct, come up and show me, and you can have a piece of candy. Hey. All right, if you get a first, you get your choice. If you get a better choice. Okay. Life is a competition. I keep telling my children it's not. All right.
Life is a race. The one who puts himself right to be first, and the one who
There you go. That's right. Pace yourself. Okay. So, let me see. This next problem, all books need to be closed. I didn't forget to say it. Now, you'll notice a lot of our examples did not come from the book this time, so you do have extra examples in your book if you're stuck at any time. Okay? All right. So on this one, you may choose which way you want to do it, either with vertical rectangles or horizontal rectangles. So here's our problem, and I will make it larger. Getting there, I'm getting there. There it is. So, you are finding the area that I am shading here. Oh, I don't want that loop outside of my area. And the functions are y1 equals x cubed, y2 equals the square root of x plus 2. Let's remember that's the top half of our sideways parabola. And y3 equals the negative root of x plus 2. That would be the bottom half of my parabola. Okay? Go.